Peru, home to one of the driest coastal regions in the world, has built an agricultural export industry worth around $15 billion a year. From greening the desert with fields of blueberries and grapes, reviving arid land with asparagus and artichokes, and growing quinoa across the Andean highlands, to harvesting millions of tons of anchoveta off its coast and raising guinea pigs in mountain communities, Peru has transformed some of the harshest conditions on Earth into a globally connected agricultural and fisheries system. What has made Peru's agricultural miracle possible? Terran Works will reveal it all in this video. Let's get started. Peru is not a place where agriculture has developed under easy conditions. Along its western coast, many areas receive almost no rainfall and are trapped between the Pacific Ocean and the massive Andes Mountains. Irrigation depends on rivers flowing down from the mountains, glaciers, seasonal rains, and groundwater reserves that are under increasing pressure. Yet paradoxically, this land that faces water shortages throughout the year can be transformed into a flood zone by El Niño within a single rainy season. In northern Peru alone, the phenomenon has destroyed around 6,000 hectares of fruit crops, threatening avocado, mango, citrus, and blueberry growing regions. Therefore, before becoming a coastal agricultural powerhouse, Peru had to confront drought, arid soil, fragmented terrain, declining groundwater, and extreme weather. But those same harsh natural conditions have also created opportunities. The dry climate makes pests and diseases easier to control. Intense sunlight helps fruit develop attractive colors, and the country's proximity to the sea allows agricultural products to enter global export supply chains more easily. Through irrigation projects, drip irrigation, greenhouses, soil moisture sensors, drought-resistant crop varieties, cold storage facilities, packing houses, and seaport logistics, Peru has transformed the desert into high-value fruit-growing regions. In 2025, Peru's agricultural exports reached approximately $15 billion, while the country continued promoting a $24 billion irrigation investment package aimed at bringing around 1 million additional hectares of land into agricultural production. Peru is now one of the best-performing economies in Latin America. On the cold, arid highlands of the Andes, quinoa has become one of the oldest symbols of Peruvian agriculture. Quinoa thrives at elevations of thousands of meters, where soils are nutrient-poor, winds are strong, temperature differences are extreme, and the dry season is prolonged. Yet it is precisely in this harsh environment that this small plant grows with remarkable resilience, tolerating cold and drought while adapting well to high-altitude conditions. During cultivation, farmers usually sow the seeds in the rainy season, taking advantage of natural moisture rather than relying heavily on irrigation systems. The fields are weeded, soil is mounded around the plants, and the flowering and seed-setting stages are closely monitored. When quinoa fields change from green to yellow, red, or deep purple, it is a sign that the seeds are beginning to ripen. In many parts of the Andes, harvesting is still carried out mainly by hand. The stalks are cut with sickles, gathered into bundles, and left to dry in the fields until the seeds reach the appropriate moisture level. The quinoa is then threshed, sifted, cleaned, and processed to remove the naturally bitter saponin layer surrounding the seeds. Grains that meet quality standards are sorted by size, color, and cleanliness before being bagged or packaged for export. Once a native staple that sustained Andean communities for centuries, Peruvian quinoa has now entered the global market as a protein-rich superfood, closely associated with the story of the high mountains, ancient civilizations, and the resilience of indigenous agriculture. Peru is recognized as the world's leading supplier of fresh blueberries, thanks to its long growing season, vast areas of cultivable land, and access to markets across Asia and the Americas. Blueberries have become the clearest symbol of how the country has transformed desert land into export-oriented farms. Unlike traditional growing regions with abundant rainfall, Peru's blueberry farms depend almost entirely on precision irrigation systems. Water is diverted from rivers originating in the Andes and distributed through drip irrigation, combined with soil moisture sensors, soluble fertilizers, and varieties adapted to hot, dry conditions. Because rainfall is limited, farmers can control pests and diseases more effectively, while keeping the berries clean, evenly colored, and less likely to develop cracks in their skins. When the berries turn a deep bluish purple and reach the required firmness and sweetness, workers begin harvesting them entirely by hand. In Peru, blueberries are not harvested by massive shaking machines, but mainly by the hands of thousands of workers. Each berry must be picked gently, with the delicate natural bloom on its skin left intact, because even a small bruise can cause it to fall below export standards before it has even left the coastal desert. After harvesting, the blueberries are quickly transported to packing facilities, where they are pre-cooled, sorted by size and color using scanning machines, and packed into small containers. From there, they enter the cold chain and are shipped in refrigerated containers to the United States, Europe, and Asia, turning berries grown in Peru's desert into premium products on supermarket shelves around the world. The most important part of Peru's fisheries industry is not its expensive fish species, but anchoveta, a small fish that supports one of the largest fisheries on the planet. Off the coast of Peru, the Humboldt Current brings cold, nutrient-rich water from the depths of the ocean to the surface, creating marine zones filled with plankton. This provides an enormous food source for anchoveta. Unlike salmon or shrimp, anchoveta are rarely raised in ponds or sea cages. They are harvested from the wild by industrial fishing fleets, operating under seasonal schedules, catch quotas, and scientific monitoring. Before each fishing season, Peru must assess fish stocks, monitor the size of the schools, measure the proportion of juvenile fish, and examine ocean conditions. After being caught, the anchoveta are quickly brought back to port and transported directly to coastal processing plants. There, the fish are cooked, pressed, separated for oil, dried, and ground into fish meal, while the extracted oil is refined into fish oil. These products are not mainly intended for direct human consumption or canned fish exports. Instead, they become key ingredients in feed for salmon, shrimp, and many other farmed aquatic species around the world. In 2025, more than 80% of Peru's total fisheries catch still came from anchoveta, mainly for the production of fish meal and fish oil. One fishing season in late 2024 alone yielded around 2.42 million tons of anchoveta, producing more than 680,000 tons of fish meal and fish oil, and generating over $1.41 billion in export revenue. Anchoveta therefore serves as a largely unseen link sustaining the global aquaculture industry, where a small fish caught off the coast of Peru can become a source of nutrition for salmon in Norway, shrimp in Asia, and millions of tons of farmed seafood around the world. Across Peru's dry, sun-drenched valleys, artichokes are among the most distinctive crops in the country's coastal agriculture. During cultivation, artichoke plants require well-drained soil, a reliable water supply, and a dry climate to reduce fungal diseases. Farmers must closely monitor the development of each bud because the most valuable part is not the fully opened flower, but the young, firm artichoke head whose leaves have not yet begun to spread. If harvested too late, the bud becomes fibrous, tough, and loses its processing value. Once the buds reach the required size, workers use knives to cut each one from the stem by hand, leaving a short section of stalk attached to protect the inner structure. After harvesting, the artichokes are quickly transported to processing plants, where they are washed, graded by size, trimmed of their outer leaves, and prepared to expose the tender heart at the center. They are then blanched to stabilize their color before being canned, jarred, or frozen under strictly controlled hygiene conditions. From a thorny flower growing in the fields, the Peruvian artichoke becomes a premium ingredient in salads, pizzas, pasta dishes, and Mediterranean cuisine, another example of how Peru has turned its arid climate into an export advantage. Across coastal desert regions such as Ica and La Libertad, asparagus is one of the crops that most clearly demonstrates Peru's ability to transform arid land into high-value agricultural exports. Peruvian asparagus is mainly green and white. It grows in a hot, dry, and sunny climate, where rainfall is extremely limited, but irrigation can be precisely controlled through large-scale water systems and drip irrigation. These low-humidity conditions help reduce many fungal diseases, producing asparagus spears that are straighter, cleaner, and more uniform. Throughout the growing process, farmers must maintain stable moisture levels around the root system, supply nutrients through irrigation, control weeds, and closely monitor the growth rate of each row. Asparagus requires a high degree of precision because the harvested part is neither a fruit nor a seed, but the young shoots that have just emerged from the soil. If left too long, the spears become mature, fibrous, and lose their commercial value. Once the shoots reach the required length, workers use specialized knives to cut them close to the base, usually harvesting early in the morning to preserve freshness. The asparagus is then quickly transported to processing facilities, where it is washed, cooled, trimmed to a uniform length, and graded according to size and straightness. Bunches that meet quality standards are packed under controlled temperatures and placed into the cold chain for export to the United States, Europe, and Asia. Once considered a luxury vegetable, asparagus has become clear evidence of how Peru has transformed the desert into highly sophisticated export farmland. Across the Andean highlands, the Peruvian guinea pig, known locally as cuy, is not merely a small household animal, but a long-standing part of indigenous agricultural culture. Unlike cattle, goats, or sheep, which require large areas of pasture, cuy can be raised in small enclosures close to the home, feeding on leftover vegetables, grass, corn stalks, and other agricultural byproducts. This simplicity has made them an important source of food for many mountain communities where farmland is limited, the climate is cold, and large-scale livestock farming is not always practical. During the raising process, households usually separate the animals by age and purpose, while keeping the enclosures dry, well-ventilated, and clean to reduce disease. Cuy reproduce quickly, grow rapidly, and require very little space. So for small farming families, they function like a living food reserve that can be maintained throughout the year. Some improved breeds in Peru can even reach market weight after only a few dozen days, helping increase productivity and household income. Once they reach the appropriate size, the animals are sold at local markets, supplied to traditional restaurants, or sent to small processing facilities. From a modest household animal in Andean kitchens, the Peruvian guinea pig has become a symbol of indigenous cuisine, representing the way Peruvians make use of even the smallest available resources to survive and thrive in harsh mountain environments. Unlike traditional grape-growing regions that depend on the rainy season, Peruvian grapes are cultivated under conditions with almost no rainfall, abundant sunshine, and water supplies controlled entirely through drip irrigation systems. This dry climate helps limit fungal diseases while keeping the grape clusters clean, the skins visually attractive, and the sugar levels consistent. During cultivation, the vines are trained on trellises to receive even sunlight and are carefully pruned to control the number of clusters on each plant. Farmers must continuously monitor sugar levels, berry size, skin color, and the firmness of each bunch. For seedless varieties grown for export, the requirements are even stricter. The berries must be uniform, the stems must remain green, the skins must be firm and taut, and the fruit must be almost completely free of scratches or blemishes. Once the grapes reach the required level of ripeness, workers harvest them entirely by hand, using scissors to cut each bunch before placing it gently into containers to prevent bruising. The grapes are then quickly transported to packing facilities, where they are pre-cooled and graded according to size, color, and overall bunch quality. Clusters that meet export standards are packed into boxes, loaded into refrigerated containers, and shipped to the United States, Europe, and Asia. From Peru's arid coastal regions, these grapes have become a premium product, supplying the world with fresh fruit even after the harvest season has ended in many other countries. For decades, American agriculture has been known for its massive scale, heavy machinery, and an almost fully mechanized level of automation. Fields stretching across thousands of hectares can be planted with self-driving tractors, monitored by drones, irrigated through sensor systems, and harvested by industrial production lines running day and night. Yet, amid all of that technology, there is still one tiny task that machines have not been able to fully replace: transferring pollen from one flower to another. And it is at this fragile point that the bee, a small living creature, becomes a vital link in the chain. According to the USDA, more than 1/3 of U.S. crop production depends on insect pollination. With around 90 types of crops, from nuts and berries to flowering vegetables, requiring this process. Honeybees are considered the main pollinating force, contributing at least $15 billion each year by increasing crop yields and improving harvest quality. Almonds are the most striking example. Nearly all commercial almonds in the United States are grown in California, and the industry reached a value of more than $5 billion in 2021. Every February, when millions of almond trees burst into white blossoms at the same time, around 68% of all commercial honeybee colonies in the United States are brought to California specifically for this short pollination season. Before a bee colony can produce honey or serve pollination, everything begins with preparing the beehive boxes. From the outside, they may look like simple wooden boxes neatly arranged in an orchard or an apiary. But inside each hive is a miniature society, with a queen bee, worker bees, young bees, wax combs, stored honey, and tens of thousands of individuals operating together like a living body. During the peak growing season, a healthy colony can contain between 30,000 and 60,000 bees, and the strength of the entire colony depends almost entirely on the stability of the queen. Beekeepers usually place hive boxes in locations with abundant floral sources, close to clean water, well ventilated but protected from strong winds, free from flooding, and with limited exposure to pesticides. The hives are often raised above the ground to reduce moisture, keep away ants and rodents, and make it easier for beekeepers to inspect them. The direction of the hive entrance is also important. If it receives morning sunlight, the bees will become active earlier and fly out to collect nectar and pollen more efficiently. Inside the hive, the frames are arranged so the bees have enough space to build wax combs, raise larvae, and store honey. Beekeepers must make sure the colony is not too weak, not too crowded, and has enough food during periods when flowers are scarce. After the hive boxes have been placed securely, the beekeeper's most important task is to check the health of the entire colony. They open the hive lid, use a light puff of smoke to calm the bees, and then lift out each frame for inspection. To someone outside the industry, the golden brown wax frames may look almost the same. But to a beekeeper, each frame is a living report. Whether the queen is still laying eggs regularly, whether new eggs are present, whether the larvae are developing normally, whether there are enough worker bees, and how much honey and pollen remain in storage. If the colony is short on food, the beekeeper may add sugar syrup or pollen patties. If the colony is too weak, they may combine it with a stronger one. If the colony becomes too crowded, they have to split it to prevent the bees from flying away and forming a new nest. In many cases, an old or poor quality queen is also replaced with a new queen to maintain the reproductive strength of the entire colony. Caring for bees is a very special kind of work. Humans do not directly control each bee, but instead read the small signals inside the hive and intervene at the right moment. A strong colony can forage, raise larvae, build wax, and defend the hive on its own. But if it lacks food, becomes infected with disease, or loses its queen, the entire system can collapse very quickly. You know, one of the strangest migrations in American agriculture is not cattle or harvesters, but millions of beehive boxes loaded onto trucks. In late winter, when many regions are still cold, apiaries from across the United States begin stacking hives onto pallets, lifting them onto trailers with forklifts, covering them with protective netting, and transporting them through the night. Bees are usually transported at night because the temperature is cooler. Most of the bees have already returned to the hive, and the risk of them flying chaotically during the move is much lower. The most important destination is California. Every February, when the almond orchards of the Central Valley burst into white bloom at the same time, the demand for bees soars. Around 2 million beehives are brought here to serve a pollination season that lasts only a few weeks. And almonds alone can use up to about 68% of all commercial honeybee colonies in the United States. When the trucks arrive at the orchards, the pallets of bees are placed between the rows of trees by forklifts. Just a few hours later, as the sun rises and the temperature becomes warm enough, billions of bees begin flying out, spreading across the vast fields of blossoms. But this artificial migration is also controversial. Long-distance transport, climate changes, limited floral diversity, and exposure to many farming regions can put greater stress on bee colonies. So behind the brilliant almond bloom lies a difficult question. Is American agriculture relying on bees or pushing them to their limit? Pollination by bees is a very simple mechanism, but it plays a vital role in many harvests. When a bee lands on a flower, it is not actually working for humans. It is simply looking for nectar to get energy and pollen to feed the larvae inside the hive. But in that very moment, the bee's hairy body becomes a natural pollen transport machine. Tiny grains of pollen stick to the bee's legs, abdomen, and thorax. When it flies to the next flower, some of that pollen is transferred to the stigma, helping the plant become fertilized and begin producing fruit or seeds. The important thing is that this process has to happen at the right time. Almond, apple, blueberry, or pumpkin flowers do not stay open forever. The pollination window usually lasts only from a few days to a few weeks. If the weather is cold, rainy, or too windy, bees fly less. If the colony is weak, the number of flower visits drops. And if the flowers are not pollinated during that short period, farmers may lose yield before the growing season has truly even begun. A single honeybee can visit around 50 to 100 flowers in one flight, and a strong colony with tens of thousands of worker bees can create millions of flower visits during peak bloom. That is why bees do not only increase the fruit set rate, but also help fruit become more uniform, seeds develop better, and crop quality remain more stable. After their pollination flights, bees also create a product that is very familiar to humans: honey. The honey-making process begins with flowers. Worker bees use their proboscis to suck up nectar, store it in a special honey stomach, and then carry it back to the hive. There, the nectar is passed through several different worker bees, mixed with natural enzymes, and gradually changes its structure. At first, nectar can contain a large amount of water, but by constantly fanning their wings inside the hive, bees cause the moisture to evaporate, concentrating the honey until its moisture content usually drops to around 17 to 18%. When the honey is mature, the bees seal the honeycomb cells with a thin layer of wax to preserve it. Beekeepers only harvest when most of the frame has been capped, a sign that the honey has become thick enough and is less likely to ferment. The honey frames are removed from the hive, taken to the processing area, and then opened with a hot knife or an uncapping machine to remove the outer wax layer. After that, the frames are placed into a centrifugal extractor. As the machine spins, the honey is flung out of the wax cells, flows down into stainless steel tanks, and is filtered to remove bits of wax and natural impurities. After settling, the honey is bottled, labeled, and sent to the market. But in the modern beekeeping industry, honey creates an interesting paradox. For consumers, honey is the most famous product made by bees. But for American agriculture, the greater value often lies in pollination. In 2024, the value of pollination services in the United States was estimated at more than $400 million, higher than honey revenue at around $361.5 million. In other words, what we see on supermarket shelves is only one part of the story. The invisible value of bees is also found in every apple, every blueberry, and every almond formed thanks to their silent pollination flights. But behind the jars of golden honey and the successfully pollinated harvests, the American beekeeping industry is facing an enemy so small that it is extremely difficult to see with the naked eye. It is Varroa destructor, a reddish-brown parasitic mite, only about 1 to 2 millimeters in size, but considered one of the most dangerous threats to modern honeybees. Varroa does not attack a bee colony in a loud or obvious way. It silently clings to the bodies of adult bees, then slips into brood cells before worker bees cap them. Inside those cells, the female mites reproduce directly on the bodies of the developing young bees. They drain nutrients, weaken the bees, shorten their lifespan, and in many cases can cause adult bees to emerge with deformed wings. But what makes Varroa even more terrifying is that it is not just a parasite. It also acts like a virus carrier, spreading many dangerous pathogens throughout the hive. In a normal bee colony that can contain 30,000 to 60,000 individuals, this decline does not happen in a single day. At first, it may be only a few weakened bees, a few abnormal brood cells, or a few small warning signs on the frames. But as the Varroa population rises, the entire colony begins to lose strength. There are fewer worker bees, young bees develop poorly, foraging ability declines, and the hive struggles to survive the winter. In recent years, many reports have recorded that winter colony losses in the United States can reach very high levels, even exceeding 40 to 50% among some commercial beekeeping groups. This is creating new challenges for American agriculture. Precisely because Varroa, disease, and the pressure of constant transportation are wearing down the health of bee colonies, the future of American agriculture cannot rely only on bringing more hives into the fields. When honeybees help pollinate more than 90 types of commercial crops, and pollination services can generate tens of billions of dollars in value each year for U.S. agriculture, protecting bee colonies is no longer just a concern for beekeepers. It has become part of food security. One new direction is technology. Commercial apiaries are beginning to use sensors inside beehives to monitor temperature, humidity, hive weight, sound, and colony activity levels. Instead of relying only on experience when opening each frame, beekeepers can detect early signs that a colony is short on food, has lost its queen, is showing reduced flight activity, or is beginning to weaken. For farms stretching across thousands of hectares, this data helps distribute hives more accurately, especially during short pollination seasons such as California's almond bloom, where around 2 million hives can be brought into orchards in just a few weeks. But technology is not enough if the agricultural landscape remains too monotonous. In many industrial orchards, flowers bloom densely for a short period and then almost disappear. Bees may have an enormous food source for a few weeks, but after that, they can suffer from nutritional shortages. That is why many farms are beginning to plant cover crops, wildflowers, biological hedgerows, and strips of native plants to provide food for bees before and after the main bloom season. However, the debate still remains. Farmers need high yields, beekeepers need healthy colonies, and conservationists worry that commercial honeybees may compete with native bees. After years in which winter colony losses in the United States have frequently remained high, sometimes exceeding 40%, the question is no longer simply how to have more bees. The real question is, how can we build an agricultural system that does not exhaust the very creature keeping it alive?